Today we're doing section 6.6. It's finding rational zeros. So our goal is to find the rational zeros of a polynomial function. Today is very similar to what we did yesterday. It's just kind of taking it a step further. You'll be given less information, even though you're trying to find the same things as we did yesterday. It's very similar to that last section on your homework. You definitely want to write this down. So the way that today differs from yesterday is yesterday they gave you one of the zeros. They said k equals -2, and then you started your synthetic division with -2. They're not going to give you that today. Today what we're going to do is list all the possible zeros and keep testing them until we find one that works. So the beginning of the process is a little bit longer today, but if you're a good guesser, it's not too hard. But here's how we find the possible zeros. So you take the factors of the constant, remember that's always your last term, over the factors of your lead coefficient. Those are all the possible zeros. And then we just kind of narrow it down, test them as we go. Once you find one that works, you use synthetic division. It kind of makes things a little easier, and then we can usually solve by factoring from there, just like we did yesterday. So here's a quick example. If you want to write this down, you can. We're going to do a bunch more examples. This is just kind of showing you what that means up in the box. So we want to do the possible factors for the constant over all the possible factors of our lead coefficient. So do you guys remember how to find factors? It's all the numbers that would multiply into that number. So what are the different ways you could make 25? 5 times 5 and 1 times 25. So those are all factors of 25. Now, we could use different combinations of different signs to get those. 1, 5 could be positive, 1 could be negative. You could use a positive 1 and a negative 25. So we need to think of all those combinations. Now, what are the factors of 2? 1 and 2. Again, we need to think of all the sign combinations that are possible. Once you list out all the possibilities, you actually have to go through and figure out what the ratio would be. So plus or minus 1 over plus or minus 1 would just give you 1. Plus or minus 5 over plus or minus 1 would give you plus or minus 5. Plus or minus 25 over plus or minus 1 would give you plus or minus 25. And then we'll go through and divide each from the top by 2. So plus or minus 1 over plus or minus 2 is plus or minus a half. Plus or minus 5 over plus or minus 2, plus or minus 5 halves. And the same thing for the plus or minus 25 over the plus or minus 2. So those are all the possible zeros for this polynomial. Then we would go through and test them until we found one that worked. Once you know one that works, it's kind of like the problems from yesterday where they told you what k equals. Kind of a long process, but once you get the hang of it, it won't be so bad. Any questions? So for example 1, I'm going to do a little prep work over here on the board. What are the factors of 6? Yeah, I always do them kind of as pairs. So 1 times 6 and 2 times 3, right? So that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Over, what's our lead coefficient here? 1. The only way to get 1 is plus or minus 1. So our possible zeros here, basically just the factors of 6. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we know one of those is going to be a solution. Actually, probably more than one, but we're just trying to find the certain one that works, and it'll make things a lot easier for us moving forward. So just pick one and test it. The one I chose to test was 1. So we're going to use synthetic division with 1 in our box. See if our remainder is 0. If our remainder is 0, then 1's a solution. If our remainder is not 0, we got to test something else. So I have 1. Remember, you need a placeholder here for your x squared term. Negative 7 and 6. This process will go pretty quickly. We're just multiplying by 1. And we do get a remainder of 0. So we know that 1 is a solution for this polynomial. Now, since we know that, we can use what we have left over and find the zeros of this one. It's kind of like factoring. If we know that 1 is a solution, we could break the original polynomial down into x minus 1. That's how you get 1 as a solution. And then x squared plus x minus 6. We already know the solution to this part. Now we can just find the zeros back here, and those will all be our solutions. All right, so can we factor that? Or can we solve that in some way? What is it? Other way. We want the bigger number to be positive, to give us positive 1. All right, when you go through and solve those, you get negative 3 as a solution, you get positive 2 as a solution, and then from our work up here, we know that 1 is a solution. Now, do you see that all 3 of these were in our possible solutions? So you're basically just taking a long list and narrowing it down. Hopefully, if you're a good guesser, you can find that first one. Once you have the first one, you can use your leftovers from your synthetic division step and then factor. Sometimes factoring doesn't work. You can use the quadratic formula. You can complete the square. You can use all those tricks we learned last semester. What are your questions? All right, here's number 2. Again, off to the side here, let's list the factors of negative 8. Well, 1 and 8 always, right? What else?
2 and 4.
2 and 4. Plus or minus 2, plus or minus 4. And then our lead coefficient is a 2. The only factors of 2 are 1 and 2. Now, I have to think of each possible scenario. So I'm going to go through and divide all the factors of 8 by 1, divide all the factors of 8 by 2. Those are all my possible zeros. So that's how we get this list on the board. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus a half, plus or minus 1 again. Then you get plus or minus 2 and plus or minus 4. So those are all of our possible solutions. Any questions how I got this list? Once you have your list of possible solutions, pick one, see if it works. The one I chose was 1. So now you use synthetic division. See if you get a remainder of 0. If you do, then 1 is a solution. If you don't, you need to try another number from your list until you find one that works. So we drop the 2, multiply it by 1, you get 2. Add those, you get 4. Times 1, take it up, you get a 4. Drop it down, sorry. Multiply by the 1. Add those, you get negative 12. So is 1 a solution? No, you need this to be a 0. It's not a 0, so 1 is out. If you had your list going, you could cross positive 1 out. Negative 1 might be the solution, but positive 1 is not. And test something else. Let's test negative 1. Same process. And as you go through, you can see that this one does give us a remainder of 0. So negative 1 is one of our solutions. Any questions on how I got negative 1 as a solution? All right, now we can use this polynomial to help us find our other solutions. Remember, it's kind of like factoring. Since negative 1 is a solution, it's like we factored out an x plus 1. This is what we'd have left over, so if we solve this part, it will give us the rest of our solutions. How do I solve something like that? Yeah, there's a couple different ways. You can add 8 to both sides, divide by 2, take the square root. You can factor a 2 out. The way I did it, I factored a 2 out, and then I used difference of squares. No matter how you do it, you should get plus or minus 2 as a solution, and then we already have our solution of negative 1. Now, some of you might be saying, well, what happened to that 2 you factored out? Well, technically that 2 is still out here, but that's not going to give us a solution, so it's not really important. You could set 2 equal to 0. 2 is never equal to 0. There's no variables, so that wouldn't give us anything. But technically it's still out there. What questions do you guys have? All right, here's number 3. Again, let's work on our potentials list. You want factors of the constant on top. We just did the list for 8. We had plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Our lead coefficient here is 1, so that's just plus or minus 1. So our potential solutions here are basically just the factors of 8. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. All right, I started with the 1. Use synthetic division. Drop the 1, multiply by 1, add it to 1, that gives you 2, multiply by 1, and so on. You guys are getting pretty good at this, so I won't bore you with all the details. But my remainder is 0, so that tells me what? It works. 1 is a solution. Then you can use the leftovers from your synthetic division to find the rest of your solutions. So it factors to x plus 4, x minus 2. So that would give us negative 4 as a solution, positive 2 as a solution, and then we already found through our synthetic division that 1 was a solution. All right, here's number 4. Let's make our potentials list. We want the factors of 3 on top, negative 3. So we have the factors of 3 on top, plus or minus 1, plus or minus 3. The factors of 2 on bottom, plus or minus 1, plus or minus 2. And then just go through and list all the potential combinations. So the 1 over the 1 would give us plus or minus 1. The 3 over the 1 would give us plus or minus 3. The 1 over 2 would give us plus or minus a half. And the 3 over 2 would give us plus or minus 3/2. So this is our potential list for this polynomial. Here it is up on the board. All right, pick one and go with it. I'll start with 1, see if it works. So we'll go through that same old process, see if we get a remainder of 0. If we do, we know 1's a solution. If we don't, we know 1 is not a solution. So it looks like 1 is not a solution. So you can cross positive 1 off the list. It doesn't work. So pick something else to try. Let's try negative 1. All right, if you have questions on my synthetic division, just let me know. Seems like most of you guys are getting the hang of it, though. So I do get a remainder of 0. So negative 1 is a solution. Now that we know negative 1 is a solution, we know that x plus 1 is a factor. We can use this to get the rest of our polynomial and solve. So that gives us 2x squared minus 5x minus 3 equals 0. Now this one's a little harder to factor, so I'm going to try it up on the board. Sorry, I run out of space on these PowerPoints often. So my multiply number, 2 times negative 3 is negative 6. My add number is negative 5. So negative 6 and positive 1. Go back and divide by your lead coefficient, which is 2 in this case. So x minus 3 and 2x plus 1 is how it's going to factor. And there it is up on the board. Now we need to solve each of these. I know positive 3 is going to be a solution. That one's easy. Here you'd subtract 1 if you set it equal to 0. And then you divide by 2. So you get negative 1/2 as a solution. And then we know negative 1 is a solution as well. And again, you can see that all of these are on the original list. So technically you could go through and do synthetic division for each of them and see which ones all work, but this is a lot easier. What are your questions on this? Factors of negative 15 are what? 1 and 15, good. 5 and 3, good. And all of them have plus or minuses because we could do different combinations of the signs and get them to work out. Our lead coefficient here is 1, so that's pretty easy. So the factors of negative 15 are our possible solutions. Then we're going to pick one and give it a shot. Start with 1. Do synthetic division and see if it works. If it doesn't work, try something else. Oh, I don't think it works. Alright, so positive 1 is out. Let's try something else. Maybe we'll have more luck with negative 1. Nope. I got negative 8. Alright, try something else. Negative 3. You go with positive 3. I'll go with negative 3, see if it works. If not, we'll try something else again. Just narrowing it down from our list of potentials. Alright, I think this one works, doesn't it? Good. So, negative 3 is a solution. Now, here's where it gets a little trickier. What polynomial do I have down here? Remember, this is my remainder. This is my constant. This is my x term. This is my x squared term. So you just have x squared minus 5. Set it equal to 0 and solve. Can we solve that by factoring? No. What can we do? Yeah. You can add 5 to both sides and take the square root. That gives you plus or minus the square root of 5 and the negative 3 that we found. So I just wanted to show you guys one before we stopped for today where it didn't factor down here. So remember the ways you know how to solve equations when the largest exponent is 2. Okay, you can get everything to the other side, take the square root. If there's no x term, you can use the quadratic formula. You can complete the square. You can factor. You're going to have to get kind of creative on some of these. Do you guys have any questions? All right, we'll stop here for today. All right, here's your homework, so go ahead and get started on that. You guys have about a little over 10 minutes. Come with questions tomorrow. Like I told you guys, we will have a lot of time to do questions on Friday. I would not recommend waiting until Friday for all questions, though. But if you do get stuck, we do kind of have some built-in time this week to get everyone caught up. Any questions?